Lesson 1.4 is on solving equations, and there are two objectives. The first is to just solve an equation, and then the second is to solve problems by writing equations. Alright, an equation is a statement that two expressions are equal. In this lesson, we will use equations to model and solve problems. Solving an equation that contains a variable means finding all values of the variable that make the equation true. Such a value or values are called a solution or solutions. Alright, and then here are the steps of solving an equation. So the first thing you have to do is simplify and combine like terms on each side of the equal sign. If you have variables on both sides of the equal sign, subtract the smaller from the bigger. And then once this is done, isolate the variable using inverse operations and solve. Alright, so this three-step process is what we're going to be using to solve equations. So in problem 1, what's the solution of x plus 4 equaling negative 12? So x plus 4 equals negative 12. Alright, so the first thing we want to look to do is to simplify and combine like terms on each side of the equal sign. So we have an x plus 4 on one side of the equal sign. Can we combine like terms to simplify? No, we cannot. Those are not like terms. Over on the right hand side, we just have negative 12. All right, so we're gonna we skip through the first step. The second step is, do you have variables on both sides of the equation? So we have an x here, but we have nothing on the right hand side. All right, so we're going to skip step 2, and we're going to go to step 3. And we're going to use inverse operations to isolate the variable. So isolate the variable means to get it all by itself. So we have an x here. We want x to be the only thing on the left hand side of the equal sign. So how are we going to do that? Use inverse operations. So we have a plus 4. So we have x plus 4. So we're going to subtract 4 from both sides. Remember, for equations, what you do on one side, you have to do the other. So if we subtract 4 on the left-hand side, we have to subtract 4 from the right-hand side. The positive 4 and the minus 4, they cancel out to be 0. So I'm left with x equaling, and then I have negative 12 minus 4. That's going to give us a negative 16. Alright, so that's our answer. Now, we can check to make sure that this is right by plugging back in to our equation. So does negative 16 plus 4 equal negative 12? Negative 16 plus 4 is negative 12, and negative 12 equals negative 12, so negative 16 is a solution. Alright, problem 2. It's a multi-step equation. We need to find the solution y. Alright, so we look, can we simplify and combine like terms on the left-hand side of the equal sign? And the answer is no. Those are unlike terms. What about the right hand side? We have 3 times y minus 3. So what we're going to do is distribute this. Distribute the 3 and rewrite it. So 3 times y gives us 3y. 3 times negative 3 gives us a negative 9. Alright, can we combine 3y and a negative 9? And the answer is no, those are not like terms. So step 1 is complete. Let's go to step 2. Do you have variables on both sides? And the answer is yes. Alright, so we have a positive 6y and a positive 3y. We're going to subtract the smaller one from the bigger because we want our variable to be positive. So we're going to subtract 3y from both sides. So we have negative 27 plus 3y equals negative 9. That cancels. Alright, we now have to isolate our y. We're going to use inverse operations. So we got to get rid of the negative 27. We got to move it to the right hand side of the equal sign. So we're going to add 27 to both sides. And we're left with 3y equaling a positive 18. Okay, we still do not have y by itself. We have 3 times y. So what undoes multiplication? What's the inverse operation? It's division. So we got to divide by 3. So 3 divided by 3 is 1, or just y. 1y. So we have that equaling 18 over 3, which is 6. And that's our answer. Now if we plug that back in, so you have negative 27 plus 6 times 6. Alright, what does that give us? It gives us a positive 9. So that side of the equal sign, the left-hand side of the equal sign equals 9 when we plug in 6. When we plug in 6 to the right-hand side, so 6 minus 3 is 3. 3 times 3 is 9. So 9 equals 9. Y equals 6 is the solution. Problem 3, we're going to use an equation to solve a problem. So flower carpets incorporate hundreds of thousands of brightly colored flowers as well as grass, tree bark, and sometimes fountains to form intricate designs and motifs. The flower carpet shown here from Grand Place in Brussels, Belgium has a perimeter of 200 meters. What are the dimensions of the flower carpet? So I drew a picture of the carpet. And we have to find the dimensions. So we're told that the perimeter is equal to 200. So we know that the perimeter, what would that equal? Well, it would equal 2 times the length plus 2 times the width. So here, we're going to let x equal the width, and let's let 3x equal the length. And let's plug in. So perimeter, and we know that it's 200, right? We're told that the perimeter is 200, equals 2 times my length is 3x, so 2 times 3x, plus 2 times, what was our width? Our width was x. So 200 equals 6x plus 2x. 2 times 3x is 6x, 2 times x is 2x. Alright, so let's solve this equation. Notice that our step 1, we can combine like terms on the right hand side, so let's do that. So we're going to get 200 equals 8x. Alright, now we don't have variables on both sides, so we can skip to step 3, use inverse operations to isolate the variable. So we got to get 8 by x by itself. So we're going to divide both sides by 8. Why do we divide? Because this right here is 8 times x. So what undoes multiplication? Division. So x is going to equal 200 divided by 8. 200 divided by 8 is going to equal 25. Now, the dimensions. How do we find the dimensions? We're going to plug 25 in for x and the 3x. I'm sorry. We're going to plug 25 in for x in those two spots. So we know that the width is going to be 25 if I plug it in here, and then the length is going to equal 3 times 25, which is 75. Alright, so those would be the dimensions of the carpet, 25 by 75. Alright, problem 4, we're going to look at equations with no solution and identity equations. So we have to answer, is the equation always, sometimes, or never true? So let's go ahead and solve. Combine. Step 1 is to see if you can combine like terms on the left hand side and right hand side of the equal sign. In this one we can. So we have 11 minus 7, so it's going to give us 4. So we're going to have 4 plus 3x equals. And then on the right hand side we have a 6x and a negative 3x. Those are like terms we can combine. That's going to be 3x, and then we're going to add 5. Now, we have variables on each side of the equal sign. So we're going to, this was step 2, we're going to subtract the smaller from the bigger. Now, in this case, they're both the same. So it doesn't matter. We're going to subtract 3x from both sides. Alright, what results is the 3x and the negative 3x, they cancel on both sides, so we're left with 4 equaling 5. Now, does 4 equal 5? No, 4 does not equal 5. So whenever you have a number not equaling another number, you have never true or no solution. Okay, either one of those. You'll either see, the equation can never be true, or you won't have a solution to the equation. Okay, for the last one, same thing. Can you combine like terms on the left hand and right hand side of this equation? And the answer is yes. So if I look at the left hand side, I see I have a 6x and a negative 2x. Those are like terms I can combine. So what's 6x minus 2x? 4x. And then I bring down the plus 5. I can't combine those. Those are unlike terms. So I'm done on the left hand side. On the right hand side, I have a 4 and a 1. I have two numbers. So 4 plus 1, that's going to give me 5. So you're going to have a 4x plus 5 on the right hand side. So now what you'll notice is the left hand side equals the right hand side. This is going to be an equation that no matter what value you plug in for x, the equation will always be true. Or you will see sometimes infinitely many solutions. Alright, so no matter what you plug in for x, the left hand side is always going to be equal to the right hand side. And again, that's an equation that is always going to be true or has infinitely many solutions. This wraps up 1.4 guided notes.